Welcome to the pre-planning meeting for the meeting to be held later between Donald Trump and Kim Jong-il. Oh no, I'm sorry. That's another group of people. Uh, this is a couple things going on in my world. I had shared a picture in Ross Ag. Am I sharing?
Not yet. No.
There it is. So I had shared a picture where I mean, Jeff, you've got a similar setup. Yours aren't sort of vertically aligned. I think your gears are horizontally aligned, and you've got an encoder on yours. I'm trying to effectively do what you did, but put, I mean, this is the axle of the rear wheel, put a big gear and a smaller gear there, turn the shaft and put an encoder on the edge of that, where I was previously trying to use the proximity sensor. I'm thinking I'll have a little bit better resolution if I, put a magnetic encoder at the end of that. At the moment, I've, changed my top gear a little bit, so to put a groove here for a, they call it a snap ring, and then this little opening, if you can pick that out of the image, the magnet would slide in there. So at the moment, I'm about to go 3D print that, and this is what it looks like when you, just before you plug the file into 3D printer. I didn't have a snap ring, so I decided I would design a snap ring. So we'll see how well that goes, if at all. So that's what I'm focused on. Again, the encoder is, I think, AS5600, and then there's a different model number depending on what output format you use. And I was going to use I2C or I2C. I can't remember what the language is, but the notion would be put the encoder, right up against there, and also have a bracket, add a little bit here in order for it to hold a STM32 board. So I would have a very short distance going between the encoder to the board, and then USB off the board back to the processor. So that's my strategy, and what hopefully I'll have some time this weekend to do that.
You may want to add either a longer support for that little shaft, or put two supports.
I'm always open for advice. Let me get back to it so I can be clear on when.
You're supporting that right in the middle there, and if you twist that a little bit, it's going to snap off or whatever. If you either
this 1-inch bracket, is that what you're referring to, or this
where the shaft goes through that vertical bracket there?
Here.
Yeah.
Right.
Yeah.
So make this wider so there's more support on that shaft. That's what you're suggesting?
Yes.
Yeah, okay. Yeah, that's fine. What's different in this photograph from as built is this is a little bit longer, so it comes right up against there. So the shaft is actually very short. But I get your point. I've actually made that a little bit thicker too. That as pictured, I think 5 millimeters in diameter, and I think I bumped that up to 8 millimeters in diameter as well.
So when you make those gears, do you have a program that does that, or you just design those by hand somehow?
There's actually a very easy to use plugin in Fusion 360 to make a you let's see if I can get to it quickly. So there's a plugin that makes it gives you maybe 5 variables to input, and spits out the gear. Let me get back to sharing, and I'll show you where I've written my instructions. So in my, Ross Slack files from Al, research, gears for encoder, this little diagram on the left is what when you launch the plugin in Fusion 360, it gives you this screen, and it gives you these variables that you input. And so what is there? 7 variables, and then it spits out a gear that's got 24 teeth and is 72 millimeters in diameter, which is where they call the pitch diameter, which is right in the middle of that tooth. So it's very easy to use. And then you move it around and adjust it a little bit, but you don't muck with, the teeth, the math that has generated the actual teeth. Does that make sense?
Yes.
And so then so the big gear was 72. I'm not sure I saved my, so then an important part is, so I was going for 24 teeth on the big gear, which is basically 3 inches in diameter. And then you keep the same settings except the number of teeth. Here, I don't remember whether I ended up with 8 or 12. I'd have to go back and look at the as-built, but that's incorrect because that's not that big. So that would give me, at 8 teeth, it would give me a 3-to-1 ratio. At 12 teeth, a 2-to-1. I seem to recall I probably bumped it up to 12 in order to get a 2-to-1 ratio. So 2 revolutions on the magnetic encoder for every revolution of the axle or the wheel. So very helpful. Fusion 360, steep learning curve, but if you've done any CAD modeling, it's pretty easy to use.
And I see you do have fairly big teeth on those gears, and that's good, because the bigger the teeth, the easier it is to line it up and not have it slip on you or anything. Because you can get gears that have little tiny teeth, but then you have to be real precise when you mount those and line them up and everything. So that works out better having the bigger teeth like that.
Did you machine how did you buy or machine your gears? Because yours looked like a sweet installation.
Those are some company makes those, and I probably found them at surplus stores is where those came from.
And then how did you get them aligned?
I put the one on the axle, so it had its own alignment, and the other one I just made an aluminum bracket that had my sensor sticking out the side, and I just put it on there. That's all the alignment that it took.
Okay, you make it sound so simple. I'm like, I don't know why it just feels harder for me. So that's what's going on in my world. Yeah, in the Fusion 360, one other point on that is if you can find somebody with a .edu email address, You can't have access to the software with a .edu email address as a student. What's going on in your world, Matt?
I was working on a diagram for the Bond Tractor software and hardware and localization. I can share that if you want to look over, see what that looks like. How does that look?
I see everything, but maybe I just need to move the images here. Yeah, I can see everything. Yeah, cool.
That's our hardware layer, and this is saved out in the Slack, in the G drive under Slack MVP. There's our drivers for our low-level components. And these are the topics up here. Fix, heading, velocity comes from GPS. IMU comes from our IMU. Wheel velocity, wheel odometry comes from raw serial Python. That's coming from the Raspberry Pi and the Teensy.
On the wheel odometry, can you scroll, let's see, go down a little bit? Oh, okay, so you've got the one Teensy.
Yeah, so the Teensy is connected to the wheel encoder, the proximity sensor that feeds into the Teensy. And it calculates how fast we're going, the velocity, and then it receives command velocity, which will tell it how fast it wants to go, and then it'll send a PWM command to this Arduino Nano, and then the Nano will control the super servo, which controls our forward reverse velocity. And then for steering control, we use the electric power steering, and that's controlled by the Citron 30 amp controller. We read in the potentiometer, which tells us our wheel angle. We compare that to the command velocity message that's coming in. And then we output a PWM command to the Citron controller, which controls the steering.
And then back up on heading, because I can see you've got the IMU plugged into the Raspberry Pi.
Yep. So we get heading from this NEMA NavSat driver. All this does is it's like a generic, it reads from the serial port, and it just reads in normal NEMA messages from the GPS. And out of that, the normal NEMA messages coming from your GPS, you'll get a course over ground, and then course over ground is what we use for heading. We also get a fixed messages, your lat long, and then we get a velocity message. And then we also get a heading message back from the magnetometer from the IMU. And this data goes into a ROS node called GPS pose, which basically just takes this fixed message and then adds in the heading. And so sometimes we use this heading and sometimes we use the IMU heading. If we're moving, then the GPS heading is accurate. If we're stopped or going reverse, then we use the magnetometer heading. Those get combined in this ROS node called GPS pose, and the output of the GPS pose goes into robot localization for filtering, smoothing. And then the output of robot localization is odometry filtered, and that's a topic that MoveBase listens to. And we send MoveBase an action goal, and then it compares where the goal is, the X, Y, and yaw are heading where we want to go with where we are. And and then it will send out a command velocity message. It'll make a plan and then send out a command velocity message, which goes over ROS serial Python to the Raspberry Pi.
Does it go to the Pi or does it go back to the Teensy?
It does also go back to the Teensy. The Teensy is listening to command velocity. So the Teensy can listen to any topic that's being broadcast through raw serial over the Raspberry Pi.
Just thinking visually how to represent that. Maybe we need a bus-like line item there that shows command velocity is being listened to by both the Pi and the Teensy. Right?
Yep.
That's awesome. Thank you for taking time to put that together.
So one suggestion maybe, like you said, is just add like the communication, like this is PWM to here, this is PWM to here, and what messages each one are listening to. Would that be helpful?
Personally, I think it would be, at least to show, that is a box called hardware. It's not necessarily a box for communications, but I think it would be helpful.
Okay.
I mean, the person that you invited to speak on Tuesday, CBQ, is that right?
Yep.
The chart that he showed that was similar to this, at least showing the ROS nodes, was he also using the same at the highest level move base? I don't recall.
Have to take a look at that and see.
Oh, hey, Selwyn. Hey, Jim.
Hey.
Hey guys, sorry I'm late.
Didn't bother me, but Matt was getting a little grumpy. He's like, where are those guys? I'm just messing with you.
That's fine. I see Jeff's gloating over his Raspberry Pi 4 score. Nicely done.
Yeah.
I think on that lawnmower project, I think they were using Move Base because he said he's using Carrot Planner for their global planner, and I either wrote their own for their local planner or they had some other thing they'd stuck in there. But so that sounds like they're using the Move Base with some various plugins on it.
Matt, were you looking for something to show?
He does use Move Base. There's a calibrate node and then the Move Base node.
And you put that drawing, is that out on the Google Drive someplace?
Yep, under MVP.
Anything else you want to share today? That's fantastic, by the way. I think documentation always helps, at least for people like me to get their head around what are we doing, and for others trying to understand what we're doing. You good?
Yep.
Jeff, anything on your mind today?
Here is that board, which it looks just like it does on the internet, so there's really no point looking at it here, but So that's what that board looks like. I did finally, even though it told me it's going to take 150 days or something to download that, I switched over to my Linux computer and it downloaded. So I got a card burnt for it, but I don't have the HDMI adapters to be able to actually fire it up. So, but I've got all the pieces here to do that. One other thing I was doing, here's what I'm doing right now. So here's my two GPS boards, and they're plugged into a Raspberry Pi there. And it's just like a Pi 3 running Ubuntu or whatever with ROS Kinetic on it. And then here it is actually running, so it's talking to the two boards. And if I fire up the here, can I do this? Anyway, if I start up the correction server, it does indeed put out corrections. And I don't have any antennas plugged in, so I can't verify that it's actually running. But for some reason, the serial ports on this are real cranky. That's what that red text is, that it's complaining it can't talk to the ports for some reason. And then after it did a retry, then it did connect. But it's acting really goofy, and I don't know what's wrong with that. I don't know if it's the Raspberry Pi itself, or if I'm doing something wrong, or what that is. So it's just the only reason to plug those in a Raspberry Pi, number one, just to prove my drivers do work on it. So if anybody wanted to use that, they could. And the other thing is, at work here, if we want to talk to a CAN, here's one of the little canned USB adapters. So theoretically, I could plug that into my Raspberry Pi and then generate the NEMA 2000 CAN messages, so we could plug this right into one of our controllers and get whatever data we want out of it. So that's why I was playing with that. And then last night I decided I thought I'm going to do some wiring on my tractor. So I wired up the e-stop switch to a couple of automotive relays that's going to switch the power going to both the main power driver for the big motor and the RC servo that's running the steering. Got it all put together and tried it, and it did nothing. Well, it can't do nothing. There's only a switch and two relays there. And I tracked it down the fact that the little crimp-on connectors I had, when I crimped it on, it didn't make connection for some reason. So but I got it far enough to find out that, once I bypassed that, then my relays did indeed turn on and off when I moved my e-stop switch. That's about all I did on that.
How did you debug that? That's like,
Well,
I don't know how I would have found the crimp wasn't tight enough.
I took my voltmeter and said, there's got to be a voltage here, and there wasn't. So I went all the way back to the e-stop switch. There's got to be a voltage here, and it wasn't there. So on the other side of the wire, there was. So it's between the connector and the wire. There was it was not getting the voltage through. So
Well, on that RPi thing, this is. Go back to when I noticed that it was coming out, these guys ran something, I don't know, John the Ripper, and I'll put the link to this in the chat here in a second, but they had Pi 4 on Raspbian at this 539, and then if you go up here on 3, or I don't know, a 3B is probably around here somewhere, but on a 3 they had 599, so it was actually deteriorating. Now maybe they were just trying to sell this Banana Pi thing, but I mean, it sounds interesting that if you guys think it's going to be super significantly better.
I just want the extra RAM that's on it, because yesterday when I was compiling and doing a CMake on this board, it ran out of RAM and everything locked up, and because these don't have any swap space, so if you're running out of RAM, it just does stupid things.
Got it.
And I finally went back and said recompile with just using one core, and that got me past that. But I think it sure would be nice to have a board with more RAM on it, just for doing a simple compile.
Anything else, Jeff?
They come in 1, 2, and 4 gigabyte, Jeff. Is that right?
Yes, they do.
Okay.
What reseller did you get it through?
I got it at Micro Center. They've got a local store here, and they always have these specials where if you come into the store, you can buy one board at whatever the reasonable price is. So I went in yesterday and got one before they were sold out. They were sold out by the end of the day.
Oh my gosh. An electronics store you can actually walk into. That's a novel idea. Someone, anything you want to share today?
Not really, but I was curious why Jeff was trying to get Raspbian on the thing. Why not an Ubuntu? I was thinking.
You're talking about the new board or the old boards?
For the Pi 4. What will you be planning on using it for in the first place?
The reason why I was trying to put Raspbian on, they just released like 2 or 3 days ago, they released Raspbian that will run on this board. So it's going to be another month or two before they get anything else that'll run on this board. So that's the main reason to not try to put anything else on it. And the old board, the Pi 3 that's laying here, that does have some version of Ubuntu, and it's got ROS Kinetic in it. So it'll be a while before the Raspberry Pi 4 is able to run ROS and all this other stuff. And Matt had mentioned the that other package from the robot something. That I'm sure that's not going to run on this until somebody goes back and recompiles it and gets the right operating system put on for it. So I don't think you should rush right out and get one, except that it was just easier for me if I could get my hands on one. Then when I finally get around to it, it'll be here and not have to go track one down. Because I don't know how long they're going to be on short supply. Maybe for the rest of the year. Or I don't know.
Yeah. Thanks. That makes sense.
Matt, do you think the Ubiquiti distro will run on a 4 out of the box?
I don't know. Maybe somebody has tried it. I haven't looked it up yet.
Jim, anything going on in your world you want to share?
No, not making any progress on hardware. I'm kind of on the software side. I did sign up for Robot Ignite and started working through some of those online courses, and quickly exposed my need to get better underpinning on Python at least, but it looks like a lot of C++ is also being used. So unfortunately, I don't have those skills, but I'm okay with Linux. So yeah, with actual farm work going on, it's I guess at this point it's easier for me to do the online course and work at night and stuff, and then instead of spending time with my hardware, I get to do things like spraying the actual crops and whatever. So
that's cool.
But guys, I always learn something. Even from Jeff's post this morning on his score, I had no idea that resource, that Micro Center store, was local. So it's got to be a candy shop. Good resource to know about. So I always learn something from you guys.
Like adult Legos, Yeah, I also spent, in the journey time, you can find a number of electronic books or ebooks or PDFs that are available that you can pick up a fair amount through those as well. So that's another path to consider in your learning journey.
Yeah, the Pact Publishing, I think Jeff turned me onto that too, and I've downloaded quite a few titles. And although they've recently changed to only being available in the online reader, I was fortunate enough to get enough early ones. So I have a pretty good library on ROS and Python and C++. More than I can digest in 6 months anyway.
Yeah, definitely. So, and your brother joined also, it looks like.
Yeah, it keeps kicking me out. I'm using this from my phone, and it kicks me out. And whenever I join in again, it would just create a new user or something. I don't know, but yeah, it's weird.
Well, again, Matt, thanks for organizing the guy to come in and talk Tuesday. I thought that was fascinating and spot on, at least at what some of us are trying to do. So that was really useful.
If you think of any other topics, we can try to find people that could come in and talk on that.
There's this company doing they're drawing lines on game fields. I forgot their name, but let me try and find them out. They're making small robots that can draw those white lines that you need on the game fields. You know, I don't know how to
That would be
explain.
interesting. I mean, they definitely must have precision to do that.
Exactly, and it's outdoors. You need GPS precision, probably. I'm just curious how they're doing it. It might be worthwhile to try and get into touch with them. I'm gonna try and find their name first.
While someone's doing that, the IMU that CBQ was using, I think it was, I don't know if it was at Adafruit or Parallax. I forgot which supplier he had.
It was the UM7. I think it's Redshift maybe is the company. I've got one laying in a box back here. We could never get it to work. Actually, the IMU would work, but we couldn't get the directions on the axes to point in the right direction. I just got tired of screwing around with it. We just threw it in a box back here. So that was our experience with those.
That's not a rousing vote of confidence, is it? Jeff's got a stock of them and gave up. Yeah, one of everything, Jeff. Two of most.
Just about. We ended up going with that Fidgets IMU, and I think it's a module you plug in, and then the ROS driver I think has the rest of the software to complete it. And one of the guys here had used that before, and he seemed to like it, so that's what we ended up buying that and putting on. Although beyond that, then they said once they decided we're going to hook it to our controllers and have to have CAN, now that really limits you to what you can buy that has a CAN interface on. And they have found a couple, and I don't recall what the names are right offhand.
My suspicion is the price went up too.
They're like $400 or $500 a piece for these things. I guess the first one we started with that had CAN. It's made by a company in Denmark or somewhere in that part of the world, and it's really stable. They've got a YouTube video showing that they're bouncing it back and forth, and they even run some magnets by it, and it stays very stable. But the problem is, when they built it, they calibrated it for wherever they live and give you no way to recalibrate it once you get it. And then the other thing was just the fact that you really can't do anything with it, as far as changing the calibration or anything. So that was another problem on that. So they bought another one that, because that one had a magnetometer in it. So they bought another one with no magnetometer. And then we had the problem of how do you know what direction you're going? So that's why they were thinking about dual antenna, GPS, and all this kind of stuff. And I think maybe the latest one they found that was a CAN-based IMU also has a magnetometer again. So I'm not sure what they got for that or how well that's working.
Let's look at what Sohan found. Wow.
It seems like that's an awful big vehicle just to put lines on your field, but maybe it needs to be.
RTK GPS. Yeah, they put an ugly girl in their ad. That's useful. +45 country code. Is that Denmark?
I don't know. That is something else annoying about the internet, because you find a company and you say, where are they located? And they will not tell you. You dig through their about and on contact us, and it's real hard to find out where they're located in the world, which, as long as they're willing to sell it to you and ship it, I guess it doesn't really matter too much, but I just find that annoying.
Yeah, it looks like it's Denmark.
I haven't seen anything about the technology. Neat. Got to do straight if you're doing the football field. You have some YouTube videos. If you search on Intelligent One, athletic field marking GPS robot. So, have you watched these YouTube videos?
I have, I think, only I skimmed through it, didn't go through all of them. There's like a 40-minute one or something I found, so I don't know. Those have to look closer. But they do say they rely on GPS and motors. There's something on their website, so I've been looking at that. Yeah, it's an interesting way. Or I hope they're using ROS. That would be cool.
Here's a little bit of a write-up on one that I found. Just post it. So, anything else?
No, just working and work stuff. So nothing I can possibly share. Yeah, hopefully I'll find some time this weekend. I still haven't printed out the circuit board that I made. I had to set up the printer, so I did set it up this week, and we'll see. I'm going to work on some, or making sure that the things that I've done actually make sense, and they're not, they work as expected. So we'll see. I haven't done much progress. Nothing that I can think of. So thanks for asking.
Okay, guys. Going. Any last minute thoughts? If not, have a great weekend. Matt, I'm assuming even though next week is 4th of July week, we're still meeting on Tuesday, right?
Yep.
Do you guys want to meet next Friday after the 4th? Or, I mean, I'm perfectly fine too, but you going to be around, Matt?
Yeah, I'll be around.
Jeff?
If I've got nothing else going on right then, I can do it. I don't have any plans, but I might forget too.
That's like, I'm not going to touch that. Something like, well, unless something better comes along, I guess I'll talk to you guys. So, and Jim, we'll be here next week if you want to join.
Okay.
Have a great week, guys.
You do. Bye.
Okay.
Yeah. Bye now.